this time I decided not to talk about polynomials. This time I would like to talk about proportionality. And there's actually two kinds. First, there's something that's directly proportional. And how you write that is actually, it's not x equals y. To say x is proportional to y, it's this kind of squiggly kind of symbol. Well, it kind of looks like that symbol that you use that means like approximately, but that means proportional. So what that means as an equation kind of is x equals ky. And now I never mentioned a k, but what you actually need to do is you need an example, and then you can find k, which is the constant of proportionality. So let's say that when y is 5, so I'm going to say when y is 5, then x is 2. So, not 2, it's a little weird. Darn it. Knock this off the table. Counter. Okay, so then x is 2. So, we know that x is ky. So that means that 5k, that's our y, is going to be equal to 2. And by the way, let's just say that we want to figure out what x is when y is 7. So when y is 7, then x is what? So let's figure that out. Anyway, we figured out that 5k is equal to 2. Let me get that a better angle. There you go. So we just need to divide both sides by 5, and we get that k is 2/5. And that is the constant of proportional. I can't fit that. Okay. The constant of proportionality. So that's what that is. Constant of proportionality, and that is, my F looks a little weird. That is basically what we multiply one variable or number by to get the other. Pretty simple. So we just need to know y to find x, basically. And then we just take the reciprocal of that to do the other way around. And so the reciprocal of k, we notice, is 5/2. So anyway, well, what's 7 times 2/5? Well, 7 times 2 is 14. And 14 over 5 is just 2, remainder 4. And that remainder represents a fraction, 4/5. So then x is 2 4/5. And you can represent that as an improper fraction. But I prefer using improper fractions when I'm actually, I prefer using them for or when I'm trying to calculate something. This time we already calculated it, so it's easier to kind of understand what mixed numbers mean. So that's why I'm using x equals 2 4/5. So what about that other kind of proportionality that I was talking about? What would not be directly proportional, but it would still be proportional? Well, that's when something is inversely proportional. So that's written like this. Inversely proportional. So, we saw that with directly proportional, when x goes up by, say, 120%, then y is going to go up by 120%. And when x goes down by, say, 50%, then y is going to go down by 50%. So they were kind of going up and down together, but they weren't necessarily equal. Well, they were just proportional to each other. So if they're inversely proportional, that should mean the exact opposite. When x goes up by 70%, say, then y should go down by 70%. Well, let's say that when y is 5, then x is going to be 2. So, once again, since this does literally mean that x is proportional to the reciprocal of y, you might have guessed this is going to be x equals k over y. So the constant of proportionality over y this time. So we're actually dividing by y. So let's try to figure out when y is 3, then x is what? So y is 3, x is what? And let me just note over here in our kind of example, we see that when y is 5, x is 2. Now that y has gone down to 3, x should go up. So let's see if we see that happen. So k over y, which is 5, should equal x, which is 2. So multiply both sides by 5, and we get k is 10. So that is our constant of proportionality, 10. So what about when y is 3? Well, we just need to plug that in. K over 3. X equals k over 3. And k is 10. So 10 over 3. What's 10 divided by 3? 3 1/3. So x is going to be 3 1/3. And sure enough, that is bigger than 2. So y has gone down and x has gone up. So you can see that there. So y has gone down from 5 to 3, and x has gone up from 2 to 3 and 3. 2 to 3 1/3. And there's one more thing I'd like to go over. X can be, this is technically this is technically directly proportional, but there's this kind of thing that you'll see sometime, which is jointly if I'm spelling proportional wrong again. I need to keep reminding myself that it's proportional. So x can be jointly proportional. And what that means, how we would kind of write that, is like this. And just to add something weird in, actually, x isn't always proportional to the variable itself. What the heck? Oh, right. I forgot to turn that alarm off. We did a virtual race yesterday. And I had a little alarm set for when we were leaving. Anyway, just to add something kind of weird in, and you do see this, there's quite a bit. I am going to kind of mess with one of his variables. Say that x is jointly proportional to, you know what? Well, here, I'll just make a note of this, but let's not go too far into this. It isn't always just the variable. Sometimes you'll see like square root of y, y squared, y cubed, maybe even the cube root of y, or z, or whatever variable. Anyway, let's say that when y is 3 and z is 5, then x is going to be, how about 20? And I want to know when y is 1 and z is 10, then x is what? Well, as usual, we find our constant of proportionality. This is the same thing as saying x equals kyz. So, well, what's yz in this example that we have? It's going to be 3 times 5 is 15. Therefore, 15k is our x, 20. So divide both sides by 15, and you get 20 over 15. And once again, since I like to, when it's something that we're not actually trying to kind of work with, I mean, like we're trying to work with it to like perform calculations, I prefer to use this as an improper fraction. So even though we could make this a mixed number, in this case, I like an improper fraction. So 20 over 15, we can divide both top and bottom by 5. So we get 4 over 3, so 4/3. And the reason that I like this as an improper fraction is it tells me multiply by 4 and then divide by 3. So what if we do that with our when y is 1 and z is 10? Well, 1 times 10 is just 10. And 10 times 4, also pretty simple, 40. Then we have the over 3, so 40 over 3. Well, let's see. 3 goes into 4 once, with 1 left over. So we bring down that 0, we have 10. And so 3 goes into 10 3 times, so here we have 13. And then remainder 1. And once again, that's just a fraction. It's a fraction of a third. So that's going to be x is 13 and a third. So I hope you enjoyed this video, and I'll see you later.